PFSs, and pharmaceutical and personal care products that affect the adult and developing immune systems. She has published just under 65 peer-reviewed publications, including 13 research papers targeting PFASs. Dr. DeWitt has also served as an external reviewer for the U.S. Environmental Protection Agency, the National Toxicology Program, and the International Agency for Research on Cancer Working Group on various aspects of the health of PFOs. Thank you.
Good morning, everybody. How's everybody doing? Good. All right, well, I'm going to talk to you a little bit about the toxicology. So I'm going to move us from the area of chemistry, which is way over my head, down to the level of biology, which we can all understand because we're biological organisms, and we'll ignore the chemistry that goes on inside of our bodies. So I'm going to talk to you a little bit about what we know about the health effects of Gen X and some of the legacy compounds to put into perspective what it is we know and need to know. I want to remind you all, though, that these compounds have pervaded multiple products. They have become part of our everyday lives because of the products that they're used to make or because of the products that are put into the products that we use. I want to point out, for example, carpeting. Surface protection for carpeting. These compounds probably exist in this carpeting here because of their stain-resistant and water-resistant properties. So I want to point out that as consumers, we have a lot of power to be able to influence companies to make decisions about what they use in their end products that we purchase. A major company has made a commitment not to use PFAS surface protection agents in their textiles. So you can support companies that make decisions that you agree with in terms of your environmental conscience. I also want to point out that Chemours also is influenced by profit. They were the 2017 Chemical and Engineering News' Company of the Year because in spite of many challenges, they still had a record year for profits in 2017. So one of the best ways we can influence how they do their business is by affecting their business at the level of profits. So we can make decisions to help to reduce environmental pollution. I also want to point out that the problem of Gen X and the problem of PFAS isn't a Wilmington problem. It isn't a North Carolina problem. It really isn't even a United States problem. It's a global problem. These compounds exist in nearly every body of water tested. These compounds are persistent in the environment. They don't go away. They get into living organisms. So this is a global issue that we need to address from a global perspective. So we have regional organizations that can work to influence change at the regional and state level, but many of us need to work together with our colleagues across the globe to help to reduce the amount of these pollutants in the environment. So because of their use in all of these different products, they are now part of our world. We all have them inside of our bodies. The question is, if we have them inside of their bodies, what are they doing to us? Are they affecting their health? And do we need to be concerned about taking in additional quantities of these compounds that are unregulated and as yet uncharacterized toxicologically? We have amazing chemists who are doing a wonderful job in identifying these compounds in various areas of the environment. We know the concentrations in many environmental media, but the question is, what gets into our bodies? And these are the questions that I address in my laboratory. So if we have compounds in water, in food, in air, do they get into our bodies? And if so, how much gets into our bodies? This is one of the areas of the toxicological world where we need additional scientists. So if there are any students out here, exposure science is a really good area to go into. It's an area that's growing, helping to understand sources of exposure and what happens in terms of them getting into our bodies. I also want to remind you that Gen X is part of a world of compounds that we know includes at least 3,000 different PFASs that have been used commercially and industrially. So Gen X is just one of 3,000 compounds that we know have been used. There have been some estimates that as many as 10,000 different PFASs might exist in the environment because of transformation and breakdown. And as a toxicologist, I can really only evaluate these compounds one at a time. So I will never go out of business if I have to evaluate 10,000 different compounds. but that's a lot of time, effort, and resource. So one of the questions that we have to ask ourselves as toxicologists is how can we approach this problem from a high throughput perspective? How can we ask questions about multiple compounds? And is there a way that we can classify these compounds to maybe understand their health effects so that we don't have to evaluate and regulate these compounds one at a time? But this is not something that's very popular with industry because they know how long it will take us to evaluate these compounds one at a time. Now, you know that Gen X is not the only PFAS that's been detected in the Cape Fear River. We know that there have been at least 11 others identified, and likely there are countless more that we are consuming every day when we drink water from the Cape Fear River. These are all of unknown toxicology. We don't have any published studies on these various compounds that have been found in the Cape Fear River. Now, when I say unknown toxicology, I say unknown in terms of what's available in the peer-reviewed literature. There likely are industry studies available that have been submitted to various regulatory agencies, but for one reason or another, independent academic scientists or members of the general public often don't have access to this information. These compounds make it into drinking water plants and into people. We know that. And then the question we ask then, can we protect ourselves in the absence of robust toxicological data? Do we need to protect ourselves? Are these compounds really a problem for our health? Do we need regulations to ensure that they're not going to get into our bodies and affect our children or our children's children? These are questions that we have to ask because maybe these compounds aren't a problem. I'm not saying that, but that is something that we have to consider as we evaluate the realm of compounds in our world. So, what do we know about the effects of Gen X in humans? Any ideas? Exactly. That is what we know about Gen X in humans. So I'm part of, with Dr. Kanapi, I'm part of a team that is helping to build a database about levels of Gen X in humans and whether or not there are any biological effects that we can detect. But to my knowledge, there have been no studies conducted on levels of Gen X in humans or effects of Gen X in humans. So how can we regulate this compound? How can we determine what a safe level is if we haven't even measured it in humans? Well, we often use studies of related compounds to make assumptions or estimates about what could happen in exposed humans. So I'm going to talk a little bit about perfluorooctanoic acid, or PFOA, the C8 compound that Gen X was developed to replace. How many of you have heard of the C8 science panel? How many of you are familiar with this? A good amount? So this was a panel that was put together from a class action lawsuit from a DuPont facility in West Virginia and Ohio, so in and around Parkersburg, West Virginia. And this led to contamination of the Ohio River and some of the drinking water sources in this particular area. As a result of this class action lawsuit, 3 epidemiologists were hired by the community to come in and study the individuals who were exposed in this community. And they were able to collect information from close to 60, 70,000 people. So it's a really great epidemiological study. And from this study, they looked at the relationship of various diseases with levels of PFOA in people's bodies. And they determined probable links that were associated with PFOA exposure. And they defined probable links as given available evidence is more likely than not that disease is associated with exposure. This is a legal definition, but it's also informative for us as scientists because it gives us information about the types of diseases that may be induced in humans that are associated with PFOA exposure, and it helps those of us who do studies of experimental animal models to determine which endpoints we're going to evaluate for future tests and for understanding the basics of toxicity. So the probable links that were identified in this particular community are listed here. There are 2 types of cancer, kidney and testicular, diagnosed high cholesterol, pregnancy-induced high blood pressure and preeclampsia, thyroid disease, as well as ulcerative colitis, which is a type of autoimmune disease. So these are the 6, if we divide the 2 different types of cancers, the 6 basic diseases for which there was a positive association with PFOA. In other words, as levels of PFOA increased, the amount of disease also increased, or the numbers of people with these diseases also increased. So we're fairly confident that in humans, PFOA is associated with disease. And these exposures are high compared to what you all likely have, but these exposures are not outside of the realm of what other communities can get exposed to in terms of PFOA. Now, we have other epidemiological studies of other human populations, and these other epidemiological studies have identified other diseases that have been associated with PFOA, or to an extent PFOS, both of these C8 compounds or legacy compounds. Developmental toxicity has been established in various human populations, and there are various changes in developmental endpoints. Alterations in cholesterol, so kids having problems with cholesterol, immunotoxicity, kidney functions, and changes in onset of puberty in females. Immunotoxicity, which is the best type of toxicity because that's the type of toxicity I study, not that there's really a best type of toxicity. But immunotoxicity is specifically associated with decreased vaccine responses. So if you go out and get a flu shot, you're exposed to high levels of PFOA, that flu shot won't be as effective, especially if you have that vaccination as a child. And then liver damage associated with changes in liver enzyme. So these are the types of human effects that we've seen associated with PFOA. And we're fairly confident that these are real effects associated with a compound and not some random confounder that's contributing to these diseases. And we also are more confident in these outcomes because studies of experimental animal models demonstrate or support these epidemiological findings. So we have to do studies in experimental animal models so that we can identify the individual compound and its particular effect. And so from studies of experimental animal models and individual compounds, we have determined that liver toxicity, developmental and reproductive toxicity, immunotoxicity, and certain types of cancer are caused by exposure to PFOA and in some cases PFOS. So we know this from experimental animal studies, and you can see that there's concordance with those epidemiological studies of humans. So we have these studies that associate changes with exposure. Are these studies sufficient to protect public health? That's really the big question. So we have these highly exposed populations. What does that mean for all of us who are getting exposed to PFOA or maybe other chemicals? What other information do we need to protect ourselves from these compounds? Well, we need to understand the concentration to which we are exposed. What are we taking into our bodies, and what concentrations do we have in our bodies? And dose is an important part of the equation, but dose isn't everything. So the concentration that we get exposed to isn't the only driver of an adverse health outcome. Dose lets us know how much is necessary, but we also have to consider other factors, such as the duration of exposure, somebody getting exposed for 5 minutes or 50 years. We have to consider the developmental stage. Babies are very different from grown-ups. So does life stage influence how somebody responds? And then what route? Most of us take these compounds in via the oral route, but we also know about, I could just get into a little bit of Dr. Knappy's time. But we also know that we can breathe some of these compounds in, and some of them get absorbed dermally. So what has the US EPA done? The US EPA went through the data on PFOA and developed this health effects support document. This is something that they can do under the auspices of the Safe Water Drinking Act. PFOA was a compound on the candidate contaminant list. And what this allows the EPA to do is to describe the toxicological effects and determine the risk to humans. The results of this analysis were published in 2016. They're readily available online. And they came up with this concept, or this number known as a reference dose. That's a pretty low number. That's parts per million. That's a very low number. And it was derived from a developmental study in mice that showed some delays in some developmental endpoints. Okay, so this reference dose can then be used to protect us from exposures. The reference dose is an estimate of an exposure that is thought to be without appreciable toxicological effects. So in other words, if we get exposed to this concentration of PFOA throughout our lives, we should not experience any toxicological outcomes. Should not, okay? It's all based on probability. These are often derived from experimental animal studies, and they're based on some other concepts in toxicology known as no observed and lowest observed adverse effect levels. But it's largely supported by this concept of weight of evidence. So if we go back here, 400 plus publications were in this health effects document. So the amount of information that we have on PFOA is huge. We've had a lot of people studying PFOA for many, many years. So weight of evidence is an important part of developing a reference dose to help us to develop things known as health advisories. And I'll skip over this. I can bring this up later if somebody wants more information about how we derive a reference dose. So what's important about the reference dose is that it's often used then to create advisories. So the US EPA created a health advisory level for PFOA and PFOS based on this reference dose. And here's just an example of how this was calculated. So the US EPA took a dose that was given to a mouse and converted it to a human equivalent dose through a pharmacokinetic model, which is a model that allowed them to extrapolate from the mouse to the human based on how quickly the compound is eliminated from the body. Because we know that these compounds are eliminated more slowly from humans than from mice. So that dose of 1 mg per kg in a mouse becomes a human equivalent dose of 0.0053 mg per kg, or milligrams per kilogram. So a much lower concentration in humans would be associated with this developmental effect. Okay, does everybody understand that? So we have to make these conversions because humans and mice aren't exactly the same. This is important because this represents our ability to translate data from experimental animal models so that we can adequately predict what will occur in humans and protect humans, especially those sensitive subgroups such as babies. Okay, so these health advisories then were based on this reference dose for development. Development was considered to be a sensitive endpoint because we know that developmental toxicity is a problem for these compounds. But what does all of this mean then for Gen X? Well, if we look at the database of toxicity for Gen X, we don't have a huge number of papers. That weight of evidence is fairly low. But if we look at some of these papers individually, we see similarities between Gen X and PFOA. So the Ray et al. Paper is a ChemWars study that evaluated the chronic toxicity of Gen X. And they determined that there was liver toxicity and that it induces this tumor triad, liver, pancreatic, and testicular tumors. The Wang et al. Study demonstrated liver toxicity and demonstrated that increases in liver weight induced by Gen X occur at lower doses than increases in liver weight induced by PFOA. So in other words, Gen X increases liver weight at a lower dose than PFOA. This study out of my lab demonstrated that there were attenuations in antibody responses. So we see similarities between PFOA and Gen X in terms of the health endpoints that are produced. The major difference appears to be dose. So it takes more administered dose of Gen X than PFOA to produce these adverse health outcomes. So Gen X is less potent than PFOA. That's what we would say if we compared the administered dose. But an interesting study came out of a laboratory in Sweden just this year that looked at some of this, that looked at the concept of internal dose. How much is in the body, how much is in the blood, how much is in the liver, and how much then of these different compounds is necessary to produce increases in liver weight. And this particular study demonstrated that Gen X is more potent than some of these other compounds, including PFOA. It takes less Gen X to induce increases in liver weight than some of the other compounds. So that means that some of these alternatives, even though they appear to be eliminated more quickly, even though they maybe appear to accumulate at a lower concentration, when we look at the concentration at the target site, that is the concentration, for example, in the liver, they are more potent than some of the legacy compounds. So looking at Gen X from this perspective, it is more toxic than PFOA in terms of its ability to affect liver weight. So more potent. So what this means for other adverse health outcomes, we don't know. We don't know what this means for immunotoxicity. We have seen that for immunotoxicity, Gen X induces toxicity at a lower internal concentration. So we have a drinking water exposure level for Gen X. based on sound science, based on scientific studies that have been published or are part of an industry database or part of a regulatory agency database. This drinking water no exposure level was based on liver toxicity from a 28-day study. Some may argue that this is too short of a study. We should have used the 2-year study instead of the 28-day study. But this endpoint is supported by additional studies. So this particular NOEL, this 0.1 NOEL that generated a reference dose, is supported by multiple studies and multiple endpoints. It's specifically for protection of bottle-fed infants, which we know are sensitive subgroups for exposure to these various compounds. And we also know, remember that picture I had of all the different source contributions. We don't know about all of the different additions of PFOA or Gen X to our bodies. So this relative source contribution accounts for that uncertainty. So we have a level that is going to protect those who are likely most sensitive to this class of compounds. So in terms of then health effects, Gen X, we can kind of compare to PFOA because it produces the same suite of effects, and for some endpoints, it may be more toxic. So even though we don't have experimental data on developing organisms, we know that they are sensitive from exposure to these compounds. So we can use information from surrogate compounds to make sure that we're adequately protecting our health and the health of our children. The next big question then is, what are we going to do about the other compounds? Are we going to do a whole bunch of experiments, or can we read across from some of these other studies to make assumptions that are going to protect our health? All right, thank you for listening.